Assalamualaikum and a very good day to my dear students. Here is Miss Hanis, and without further ado, let's start and get on with marking the first test that I've ever given you. Okay, so this is test 1. In case any one of you do not recognize this is the test that I have given you around few weeks ago. Okay, sorry, I'm really sorry for the delay. Okay, so this will be the time where you and I will be discussing on your test. So get ready with your red pen and we gonna start marking now. Okay, so make sure you are on this question now. Question 1. Okay, so this is a trial, the PSPM trial from KMJ, which is Kolej Matrikulasi Johor. Let's take a look at the first question. And as you know, this is from chapter 3, selection and speciation. Sketch a graph to show distribution of phenotypes before and after disruptive selection. Okay, and let's highlight the keyword disruptive selection. Remember, we have 3 types of selection, which are, the first one is, what is the first one? Stabilizing selection. Stabilizing selection. This is the first one. Okay, where it favors the what? It favors the intermediate phenotype. Okay, that means the one in the middle phenotype. So this is for stabilizing selection. And the second one is, what is the second one? Directional selection. When we talk about directional selection, that means it favors one of the extreme, because it has been directed to another extreme. That's why only one of the extremes. How about disruptive selection, guys? Disruptive selection. Disrupt. I've given you the analogy before. When you disrupt someone in the middle of a conversation, that means you cut someone in the middle. That means it favors both extreme. So you guys have to know which one is which. Only 3 of this selection. And I hope you guys know the before selection should be something like this. Okay, so this is before selection. And when you cut someone in the middle, okay, this one, we punch it down. So what happened to the middle? When you punch down the middle, it will be like this. So I'm gonna use the dash line so you guys can see it. So this is how it's supposed to look like. Okay, so this is how it's supposed to look like. So I'm just gonna do it again because it doesn't look good to me. Okay, this one is better. So make sure when you do this, the one in the middle here should be lower than the before selection. And please guys, please remember this is a graph. So when it is a graph, you have to label it. So let's label it together. So for this one is a before selection. Okay, before selection. And this one is after selection. Please do not forget to label the graph, or else the examiner would be confused which one is before, which one is after. So if you get correct curve with label, okay, remember with label, you will get 1 mark. Where is the another marks? Of course, the axis. This is graph. Okay, so you have to label the axis. This is number of individual. Okay, so this is number of individuals, and this one is phenotype. Then only then you get 2 marks. Okay, 2 marks. Done. This is too thick, don't you think so? Let me just change this real quick. Oh, no wonder it's too big. Okay, this one is better. So let's take a look at the next question. Explain how the above selection occur. So now you have to explain it. How? So you can say, look at the notes on this side, on the right side. Okay, guys, the notes on the right side. It favors both extreme. Okay, you can do that. So what favor both extreme? You have to remember this is natural selection. Natural selection. So we can say environmental condition. Okay, environmental condition favor individuals at both extremes. Okay, you have to set both extremes. That is the first mark. Or you can say, what is the opposite of favoring someone? Eliminate. Okay, it select against. You can use that keyword. Or select against the intermediate phenotype. So if you put either one of these, you get the mark. Alright, guys. So for this one, done. 3 marks. And let's take a look at this cute little penguin. Please read it carefully. You guys always seem to forget to read, so let's read together. Figure 1 shows Eudiptis skegeli, royal penguin, breeding season in October to late February, and Eudiptis chrysocom, southern rockhopper penguin, such a long name, right? Breeding season early March to late in June. March, oh, interesting. They may encounter during migrating season in the same area. So they say now it's the same area. But look at this. It says here, this one breed in October to late February, but this one early March to June. How can they see each other if they breed in different time? So remember our acronym. Happy birthday to my girlfriend. So H is habitat. B is behavioral. T is temporal. So temporal is about time, tempo. So you have to say temporal isolation. Okay, because they want to know the type of pre-zygotic reproductive isolation. So the one that we have covered here is pre-zygotic isolation. Right? So this one is for the first one. The second one. Explain how pre-zygotic reproductive isolation in B1 ensure both species does not interbreed and cause successful speciation. So this means how can temporal isolation ensure both species does not interbreed? That means they don't want these two to interbreed. Okay, they don't want that to interbreed. Okay, no, big no. So that is why this one penguin will go out. Okay, will go out to mate around October to February. But this one, March to June. Different season. So you can say different species. Okay, different species breeds at different season or different time. Okay, so if they don't see each other, they won't breed. So that's how it works. Okay, remember, if no jodoh with your crush, you guys have class in the morning, your crush has class in the evening, how can you guys see each other? Right? So same goes to this penguin. Okay, it has been separated due to the seasonal mating season. Okay, that is only the first mark. How about the second mark? You can say, So this means it prevents, okay, it prevents from fertilization. Because they won't see each other, so no mating, no fertilization between gametes. Alright, so this is the second mark. Done. So you're expected to get full mark, 6 marks for this one. Right? So 6 marks. Let's take a look at question 2. Question 2 is from chapter 4, biocatalysis. I hope you guys can remember about this chapter. Okay, we have covered this not too long time ago. Figure 2 shows reaction. What is this? Shows the reaction. I think there must be a bit typo there. Okay, so figure 2 shows. I think they're meant to say reaction. Okay, so let's just ignore that. Let's look at here. Based on figure 2, identify the type of cofactor and class for enzyme M. Cofactor, please. Cofactor, we have 3 types of cofactor. Do you remember? Try to pause this video and try to let it out first. What are the 3 types of cofactor that we have learned before? Pause this and then play it again. Alright, so the cofactor that we have learned is, the first one is metal ion. For example, K plus. What else? Fe 3 plus. So this is metal ion. And the second one is coenzyme. Okay, coenzyme. What are the example of coenzyme? NADH. FADH2, the one that we have learned in chapter 5, cellular respiration. So these 2 are coenzyme. And number 3 is, what is number 3? Prosthetic group. Why can't I? Okay. Prosthetic group. The third one is prosthetic group. Prosthetic group, heme group, or iron sulfate. So this one bind very tightly. Bind very tightly to the enzyme. Very, very tight. But metal ion and coenzyme, they can dissociate easily. Okay, is that clear? So, identify the type of cofactor. Look at this. Oh, now we can see NAD plus, NADH. Of course, these are cofactor. Which are? I just realized I haven't given you the answer, my bad. Cofactor, which are? Coenzyme. Done. And the second one, they asked for the class for enzyme. This one. Hit lol. Class for enzyme is hit lol. The only answer that I accept is O, oxidoreductase. So enzyme M is oxidoreductase. Why? Because it has been reduced here. NADH has been reduced. My bad. NAD plus has been reduced to NADH. That's why when it comes to oxidation or reduction, automatically oxidoreductase. It's not transverse. It's not lyase. I've seen some of your answers. It's not that. If you see it's about oxidation reduction, automatic the answer is oxidoreductase. Okay? So B. How enzyme M is affected when it is subjected to low temperature? 3 marks. So you have to know, you have to remember how to explain to this phenomena, low temperature. Okay, so remember when it comes to temperature, we are talking about what? Kinetic energy. Yes, good, kinetic energy. So, enzyme M is affected when it is subjected to low temperature. Kinetic energy. Let's put down at low temperature. What happened to the kinetic energy at low temperature? The kinetic energy is low. Remember, when it comes to kinetic energy, we are talking about the movement as well. So put it down here. These affect the movement of the molecule which becomes slower. 2 marks. We need another one. So when the molecule is too slow, this actually decrease the chance of substrate to collide with what? To collide with the enzyme or with active site of the enzyme. That is better. Because the substrate has to bind to the active site of the enzyme. Done. 3 marks here. What else can you put? You could say or less formation of escape, ESC. So ESC is enzyme substrate complex, right? And of course you have to say the outcome, the effect. What happened? If all of this happen, then the rate of reaction, or you could say the enzymatic reaction, is low. Okay, so when it comes to this kind of question where you have to write down more than 2 marks, in this case 3 marks, make sure to write down one by one. Okay, so you have to talk about the kinetic energy, then talk about the movement of the molecule, then talk about the chance of substrate to collide with active site of the enzyme. Then the final one is rate of reaction is low. I kind of realized that you guys tend to write down the final outcome. The rate of reaction is low. Then you only get 1 mark. You don't know how to fry the question. So what you have to do is you try to be like, okay, why the rate of reaction is low? Then go back, reverse engineer, then you get these answers. Okay? So this one is for B, 3 marks. And C, quite a long sentence there, but we are going to try to dissect it, right? Succinate is the substrate. Okay, succinate is substrate. I'm going to put S here for succinate dehydrogenase. Okay, because I see succinate dehydrogenase, of course, this is enzyme. And hopefully you guys remember from chapter 5, this is from complex. 1, 2, 3, or 4. Okay, you guys are good. Complex 2. Okay, to form fumarate. Okay, so fumarate is the product. In the presence of malonate, the production of fumarate is reduced. Okay, that means fumarate is reduced. The product is reduced. Presence of malonate. Of course, this is inhibitor. So this question is quite tricky. They don't tell that malonate is inhibitor. They just say the effect of it. Okay, the effect. So now you know, if it's reduced, of course, malonate is inhibitor. In what way to increase back the production of fumarate? So they are basically asking how to increase the rate of reaction of enzyme when inhibitor is present. What do you do? Increase the... Of course, we have to increase the concentration of substrate because that is way cheaper. Okay. Or if you want to say succinate, okay, sure. Why not? Because succinate is the substrate. Can? Done, 1 mark. Don't put enzyme. Enzyme is too expensive. Enzyme, you can only increase enzyme if they ask about non-competitive reaction. My bad. Non-competitive inhibition. Then you use enzyme because if you increase the substrate concentration, no use. It won't change. So this one, you increase the concentration of enzyme. Okay, so this is the part 1 for test 1. I will be uploading another video for part 2. So make sure to check part 2. Oh, before that, this one, you're expected to get 6 marks as well. Okay, so 6 marks for this one. So hopefully everyone gets 12 marks, full mark, right? Okay, for the part 1. So make sure to check the video for part 2. Thank you for listening. And of course, if you have any question, just send me a message through Telegram. Or make a consultation with me. Okay, I'm waiting for you guys. Keep studying and don't forget to rest. And I'll see you later. Bye.